Goal 5.4, our last goal for goal 5 on solving rational equations. Solving rational equations, which are equations which involve x's in the denominator. I am going to be using the same concept that I used back in goal 2.4, possibly 4, possibly 3, I don't remember. It's one of those, 2.4, 2.3, or 2.4, where we cleared an equation of fractions. So let me remind you just real briefly what we did there. So if I had something, for example, that had 1/2 x plus 3/4 equals 1/3 x minus 1/6. Okay? Back when we did these, you might even have something like this on your review, I can't remember. Okay? When we cleared an equation of fractions, we found an LCD. So like in this case, my LCD would be 12. And we took everything times our LCD. And then that canceled all of our denominators. So like 2 into 12 went 6 times. 4 into 12, 3 into 12, 6 into 12. Okay? We did that. I don't need anything. Thanks. That's what we did back in goal 2 somewhere. Okay? I'm using exactly the same concept as that, but now I have rational equations. So I still have to find an LCD. And you find an LCD the same way you did in goal 5.2, where you find it when you add and subtract. I got to find the LCD still. I'm going to multiply every term by the LCD, and I'm going to cancel, just like I showed you with those 12s. And then I'm going to get an equation. That's going to be our new part for today. Once we get that equation, we should have stuff we know how to do. Solving, which we did back in goal 2. Okay? Some of you may find a shortcut along the way, and I'm going to talk about it, but not at the beginning, because I want you to I want you to see what's going on mathematically before I would show you any kind of shortcut. And I'm not going to do the shortcut. I think it's that important for you to see it mathematically correct. And if you catch the shortcut, then you can use it. Okay, so first one here, my LCD is the quantity x minus 1 times the quantity x plus 2. So I'm going to multiply every term in the equation by the entire LCD. So then what happens is my denominators should cancel out. So my x minus 1's cancel, gone. And on the other term, my x plus 2's cancel, gone. And I take what's left and multiply it out. So 2 times the quantity, x plus 2. Distribute, and I get 2x plus 4. And on the right side, I distribute 3 to the quantity x minus 1 and get 3x minus 3. That's the new part today. Eliminating my denominators from my rational equation, and then I get an equation that I should easily know how to solve. Okay, so I'm going to continue solving that. So back from goal 2. X is to one side. Doesn't matter which side. I like the one on the left usually. So I get negative x plus 4 is negative 3. Subtract your 4. So I have negative x is negative 7, and divide by negative 1, and x is positive 7. So our answers are numbers. We're solving, so our answers are going to be values, numbers. Question on that. Now, it is important that you know that sometimes your answer is not your answer. Okay? Because it's got to work. It's got to work in the equation. So, let me just show you this real quick. You don't have to write it down. 2 over 7 minus 1. 7 minus 1 is 6. 2 over 6 would reduce to 1/3. Over here, 3 times 7 plus 2. 7 plus 2 is 9. 3 over 9 reduces to 1/3, so it works. The only time it's not going to work is if, when you plug it in to the denominators, you get a 0. You can't have a 0 on a denominator. So all you need to check is the denominator. 7 minus 1, 6. 7 plus 2, 9. Not 0, not 0. 7 works. So if your solution gives you 0 in a denominator, it's not a solution. Okay? And I'll get one like that so you see. Okay, my next example. My LCD is 5 times the quantity x minus 2. So again, we find our LCD just like we did when we did goal 5.2. We don't do anything different to find the LCD. So I multiply each term by the entire LCD, and then that means that I'm going to cancel. X minus 2 is on the first one. 5 is on the second one. Nothing to cancel on the third one because there was no denominator. So I have left 5 times the quantity, x minus 4, so that means distribute. 5 times x, 5x, minus 5 times minus 4, minus 20. Watch your subtraction here. Let me change it to a different color. Watch that subtraction. Okay, because I'm going to distribute. I didn't cancel my 5. I did cancel my 5. I'm going to distribute my 4, but I'm going to distribute a negative 4. So negative 4 times x, negative 4x, or minus 4x. And then negative 4 times negative 2. So imagine that's probably the biggest mistake I find. Equals, and then 0. Don't distribute there. 0 times anything is 0. So then I solve. So put my x's together, put my constants together, equals 0. Get x alone by adding 12, and x is 12. And I plug it in to my denominators only. 12 minus 2 is a 10. There's no x there to put there, so it works. So x is 12. They get harder, I'm just going to tell you. Aww. I know. Don't mean to disappoint you, but. Okay, my next one here, my LCD is 12x. So 12x here, 12x here, 12x here. And then I cancel. Let me go to a smaller one here. So my x's, my x's cancel with x. My 4 cancels with 12, but makes it 3. And my 12 cancels with 12. So I'm left with 3 times 12, 36, minus 1 times 3 times x, 3x, equals 1 times x, 1x. And then I get an equation that I can pretty easily solve. I am going to bring x's to the right side on this one. So I'm going to add 3x. So I have 36 equals 4x. And divide. And x is 9. And if I go back and plug it in, and I put a 9 for x, it's going to be 9. That's not 0. So it works. Now, on this next example, just like when you added and subtracted, sometimes you have to factor to get the LCD. That is the case here. I have a difference of squares. So x times x, 4 times 4, plus and minus. When I go to get my LCD, I should recognize now that I have inverses. And just like when you did addition, subtraction, I'm going to make them alike and make that x minus 4, which makes this now addition. So that process is exactly the same as Goal 5.2 that we did. If you have inverses, you're going to change them to be alike by taking out that negative, which changes the operation. So now my LCD is x plus 4, x minus 4. So on the first term, x plus 4 and x minus 4's cancel, gone. The second term, x minus 4's. And in the third, x plus 4's. And then I'm left with 2, nothing left to multiply because everything canceled. Plus 1 times the quantity x plus 4 is just x plus 4. Equals 3 times the quantity x minus 4. So distribute 3x minus 12. And then we solve. So collect your like terms. On the left, so x plus 6. Subtract 3x, because I like x on the left most of the time here. But it doesn't matter which way you bring your x, as we know from Goal 2. If I brought x's to the left, my constants go to the right, so subtract your 6. So minus 2x is minus 18, and divide, and x is 9. Is 9 good? 9 plus 4, 13. 9 minus 4, 5. 9 minus 4, 5. 9 plus 4, 13. So we're good. 9 works. 9 is good. Before I go to the last two, which are harder, I want to point out the shortcut, which some of you may have seen already. So it kind of uses what we did with addition and subtraction. So I don't teach it this way, but I do it this way personally if I'm doing it on a piece of paper myself. Okay. So like on one, let's just look at that last one. I would say to myself, gosh darn it, I wouldn't say that. I would go, okay, I looked at my question, I factored, I've done my inverse, I'm going, okay, my LCD is x plus 4, x minus 4. So I would say LCD equals x plus 4, x minus 4. And like I did with addition subtraction, I would say, okay, this one doesn't need anything. This one needs the x plus 4. And this one needs the x minus 4. And that's all I would write up there. I would not write the entire LCD. But what you have to know is that when you do that, you're mentally canceling all those denominators out. That's what you're doing by taking a shortcut. You've got to know that when you do that, there are no denominators left. Okay? That's why I don't teach it that way, because I want you to physically see me canceling out the denominator. Okay? I don't care if you use a shortcut, because you know what's happening is everything that's canceling out is what we don't need. Everything that's left is what we need to form that LCD. So I don't care if you use a shortcut. It definitely is a shortcut. If it works and you understand it, use it.